Okay, I've got some questions from you. Again, this is regarding section 5 on transmissions. I formulated some questions for you, and they're available on Blackboard. I realized I have numbered 25, question 25 twice. First question is about number 11. And it says solve for a total force does not make sense according to the formula given. Well, problem is there is a typo. So total force is rolling resistance, aerodynamic resistance, and climbing resistance. So this should be a plus. Okay. So not equal here, but rather plus. Okay. So let's go and look at the question in a bit more detail. I have here free body diagram. Remember, free body diagram. This is a basic concept body diagram in mechanical engineering. If you are hesitant in doing drawings, then you're hesitant to draw free body diagrams, then you have a problem solving this type of problems. Anyway, it shows the wheel and not showing just one wheel of the two that are driven. I'm not showing the reaction, although maybe I should, reaction at the axle shaft, and then there is normal force. Oops. Normal force would be here. But what we care is the torque producing forces. There's the friction force at the wheel. We assume we have enough friction available to move the vehicle, would be to the left. So we've got the total force according to the corrected equation. So total force is rolling resistance, aerodynamic resistance, and climbing resistance, and I have values for each. It will be 200 plus 400 plus 1000, 1600. Two wheels divided by 2, so we'll have for this one wheel we have equals 800 newtons. Maybe if I change this to the original red color, okay. And then for the torque, that's trivial. We have the radius 1/2 meter, so the wheel torque is going to be equal to the radius of the wheel, that is 0.5 meters, times the 800 newtons. So this is 400 newton meters. Okay. Now for the crankshaft torque, given the transmission ratio and efficiency, we're going to see the torque wheel divided by the transmission ratio and also divided by efficiency. That's eta, and that's about it. Okay, so oh, and one more thing, because this is just one wheel, I need to multiply by 2. So the calculated wheel torque multiplied by 2, because we have two driving wheels. At the crankshaft, the torque is reduced by the transmission ratio, but it gets amplified, so that efficiency, which is less than 1, needs to act to where it's increasing this torque. So that's why I'm dividing with. Okay, so this is it. Don't forget, free body diagrams. Further questions that I've got were about Don't know how to solve questions 21 to 25, and there are two 25. So one is about the synchro mesh. So let's look at the synchro mesh first. I recommend you to I'm using, as you can see, a free tool to record my class. So there are a number of good YouTubes explaining like how manual transmission works and other things. So
the struts to the left and to the right.
The synchro mesh has a central hub and is attached with splines to the shaft, and then there are these pads, what they're called, and this is the sleeve, and when you slide it, it's later in the video, so when you slide it, it moves the pads, and you have, it's better explained in the video, so you have a difference in rotation between the gear that you want to engage with the shaft. So for that reason, there is some torque that causes the this in between bronze cone to move out of alignment, and you cannot force the sleeve all the way to where teeth here engage with the teeth on the gear that you want to connect to the shaft. So connecting to the shaft will be via the synchronizer sleeve. Okay, in the actual book there is a figure, and it shows the synchronizer a bit more schematic, so I could copy and paste. Let me save this file, save as, downloads. This means delete in Romanian. Paste, okay, and so again we have and not all parts are labeled in this figure, so we have the spline hub of the synchronizer. It's attached to the shaft, and then so it's attached to the shaft here, and then to engage one or the other of these gears, so I have gear 1 or the other gear, I need to move the synchro sleeve until this engages with this. In between there is that bronze cone, the synchro cone, which essentially gets in the way when there's relative motion, and there's some friction torque generated between the conical surfaces of there are three conical surfaces here, one of the actual gear, one of the synchro cone, and one of the synchro sleeve. So the short answer to the question is, when you engage, so when you shift the sleeve to the right, together with it, there will be another piece that's sliding these pads here, or I believe they called them struts in the video. Okay, so the two move to the right. Okay, so that was the second question, 25, and we had 21, 25. So let's see what else we have. So 21. How many gear pairs, including a final drive, mesh under load? So gears including a final drive mesh under load and transmission in figure 6 is in top gear. We go to the chapter and let's find the figure. is this one. We're going to take a screen shot, paste it, turn this, and select all. And let's see. This is a 5 plus reverse transmission, and in the question was for sorry, not that was for in the Top Gear. Okay, so let's look at Top Gear. So in Top Gear we have the following path. Input is from the clutch, and we have in Top Gear is an overdrive, so we're having a transmission ratio that is the lowest transmission ratio. So we have a first gear would be here, a small pinion meshing with a large gear. Here we have a large pinion that is the input gear meshing with a smaller than it gear that is driven. Okay, so the path would be this way, like so. Here we have the synchronizer, and then goes like so, in this way, and then to the wheels. Okay, so the answer to the question is, in the Top Gear I have 2 pair of gears meshing. Okay, next question. How many gear pair, including the final drive, mesh underload when the transmission in figure 8 is direct drive? We had the final drive shown, so this is the final drive, but on the other figure the final drive is actually not visible, so we need to account for that too. So a final drive, let me take a screenshot. So a final drive would be at the end of the propeller shaft, and that's where we have a high weight gear in most cases, so bevel gear. So if we include that one too, we need to add 2 more gears to the count. Okay, this is a lay shaft transmission. Input is from the left, and in Top Gear we have an overdrive. So the way it goes, it's like so, and this is the first pair of gear meshing, lay shaft, and then we go here to the wheels, and there is where we have the final drive, the differential, inside of the differential. So it will be the high weight gear over there at the, so we need to include this one too. If I asked including the final drive, okay, include that. Alright, so 1 pair of gears, the other pair of gears, and another one. So 1, 2, 3. Okay, so you'd expect the efficiency to be slightly less just because of that. You have more gears, an extra pair of gears under load, the efficiency will be slightly less. The advantage of this transmission is that there is a direct drive. Let's see, is there a question about direct drive? Oh, okay. Answered Top Gear, answer 24. 23. So let's look at 23, which is the direct drive, and I started saying that it's an advantage of this transmission. So print screen again. I go to Paint, Paste, Select all, and the the direct drive now is when this synchronizer sleeve, it's shifted to the left, and essentially I have the input shaft is locked together with the output shaft. So in this case I have only a pair of gears meshing, and that's at the final drive, at the differential. Okay, so there'll be just two gears meshing under load. There are other gears that mesh but not under load, so the efficiency is the highest in the direct drive. In overdrive I have 3 pairs of gears meshing. Okay, show the power flow path in the first gear for the transmission in figure first gear. Well, since we're here, I don't have a question, but we can discuss about how reverse gears are achieved. So for this transmission, reverse gear, it's synchronized, and you get it with the same synchromesh as for the overdrive. So to engage the reverse, I move this synchronizer sleeve, and I make the shaft in this gear as a single rotating unit. And in reverse, motion goes this, or power goes this way to this gear via the idler, which is in a different plane. It's brought here just to show that it exists. This is an idle gear that serves to reverse motion, and then this way and to the rear axle. Okay, so this transmission has the reverse synchronized. In the first gear, was that a question? So first gear, okay, first gear is going to be this way. It's other than direct drive, I'm always going to see meshing under load this first gear pair, and then I'm looking for the highest reduction. In high reduction, you get it in the first gear, and this is the power flow path. So, and of course via the synchronizer if you want. So synchronizer and to the output shaft. Okay, so to engage the first gear, the synchronizer sleeve, it's to the left. Let's see, 18 minutes of recording. As for the other transmission, I do have to take a screenshot. So the first gear as well as reverse, we're going to discuss in addition to the questions that are posted originally, the reverse gear. So what do we have? No, it's this one, and it's red, and it's the thickest. I'm looking also at the size of the gear. So this is the smallest of the pinions. They grow in size as we get into a higher gear. So the actual first gear is going to go this way and via the synchronizer to the final drive and to the wheels. Okay, so I'm looking again at the size of the gears, and this is the smallest one. This is the next inside, will be third gear, fourth gear. In direct drive, as you can see, there's further increase in diameter. The reverse for this transmission is not synchronized. The way it works is you have this synchro mesh, and so there's this synchro mesh sleeve, and the synchro mesh sleeve has teeth to it. Okay, one and this. So it has three positions. Of course, there will be a neutral. The way it's shown right now, it appears to be that is in. Although the idler is not very clear, so the idler could be the one that's very likely that's going to move along its axis and provide the reverse. But we don't have synchronization for the reverse. We have synchronized first gear. We have synchronized second gear. We don't have a synchronized reverse. It could be either a in-between position of the sleeve where I have the reverse pinion with the idler, which is not shown, and the teeth of the synchronized sleeve meshing, where I may have the idler being brought into engagement. Okay, so again, the first gear goes this way to answer the question in that I formulated. And okay, power flow. I think we answer all these questions. Okay, so this being said, I'm going to stop the recording. Let me know if you have additional questions. There will be a quiz on Thursday.